Good evening, students. Welcome to Biochemistry Simplified. I thank you all for the subscription. I thank you all for the views. I thank you all for the comments. Let's keep on viewing, and I hope we've been able to learn something new or to already know what we couldn't understand previously in biochemistry. So today, I want us to talk about water. Very essential for life. Very important component. Much have been said about the biomolecules, meaning we've discussed of the carbohydrates, of the lipids, of proteins, but I'm yet to talk about the nucleic acids. One of the uploads will be on nucleic acids soon. But before I dwell onto nucleic acids, let us talk about water. Very important. Even when you're looking at the structures of the monosaccharides as we were drawing them in the linear form, remember we were balancing the OH and H because they are defining the monosaccharides as polyhydroxy aldehydes and ketones because the presence of hydroxyl group. We already learned much about the characteristics of water in class, if you can recall. The dipolarity, hydrogen having a positive charge, oxygen having a negative charge, the formation of hydrogen bond, ideal biological solvent. Even in proteins, we are talking about the amino acids which are water soluble, the presence of the OH. We are talking about the carbohydrates, the monosaccharides, the presence of the OH there, the peptide bond, release of water. So even in the biochemical reactions, if you talk about the metabolic pathways, the metabolic processes, we are talking about digestion, we are talking about absorption, we are talking about degradation, synthesis, excretion. Water is involved. Even in the organelles, we talk about the cytosol. Most of it is water. The cell membrane, water. So water is a very important component. Today, we have to mention a bit about water, but I'm going to dwell much on how to derive the neutral pH of water. Remember, among the characteristics of water, we mentioned the last characteristic. Water can also act as buffers. It can either act as an acid or as base. Remember the role of buffers. They maintain the physiological pHs of our systems, be it in vivo, be it in vitro, in the labs, the buffers. So water can also act as buffers. So we live in a planet which is dominated by water. Almost 70% of the Earth's surface is covered with this simple molecule called water. But there are a bit of the importance of water to living organisms. So what justifies the study of water? Point number one, it's essential for life. So the major constituents of all life forms. If you look at those biomolecules, look at those organelles, there has to be presence of water. And leave alone that, we talk much about most animals and plants contain more than 70% water by volume. So without water, life including of those humans would have probably never have developed in this planet. We are talking about at the point of conceiving, conception, the fetus. We are talking about the amniotic fluid. The fetus has to stay in an aqueous environment. Still, we are talking about water. Even at the time we are giving birth, even our systems, for us to make us complete, it's essential for life. For us to be living, water. Parts of our body, the high percentage is water. So it's very important. Second point is molecular components like proteins. They will assume shape in response to water. So we are talking about a practical which we could do in secondary school. I think it should be in Form 1 or Form 2, where we are talking much about flaccidity and turgidity. So when it was flaccid, there was no liquid inside. But when it's turgid, so it will assume shape based on the response to water. Then the metabolic processes, of course, mostly we dwell much on degradation and synthesis of those biomolecules. But we should also remember the absorption together with the digestion also requires water. So those synthetic and breakdown reactions, they need water. Enzymes which catalyze those reactions, there has to be. Those reactions have to take place in aqueous environment. So it shows us how important water is. So by looking at those characteristics where we talked about the crystal structure of water, dipolarity of water, ideal biological solvent, buffers, cohesion and adhesion forces, all contributes much to understand how important water is to living. So when water is dissociating, we have the KEQ. The KEQ is the dissociation constant of water. It will dissociate to give us hydrogen ions and hydroxyl ions. So the KEQ value is always constant. It is 1.8 times 10 to minus 16. Given the KEQ value of 1.8 times 10 to minus 16, prove that the pH of water is 7. So you'll have to use the KEQ to derive the pH of water as neutral, that is 7. So the KEQ is also equivalent to KW. The KW is always known as autoprotolysis constant of water. So given this value, the statement says, prove that the pH of water is 7. So the KEQ, or the constant for dissociation of water, we equate it to hydrogen ions concentration, hydroxyl ions concentration, meaning the ions which are to the right after water dissociating, over the concentration of water. That is the first step. Put KEQ equals to hydrogen ion concentration. Remember, the concentration should be square bracket, not the normal bracket. The square bracket shows concentration of hydrogen ions, concentration of hydroxyl ions, concentration of water. Then you already have the KEQ value. Next is we have to calculate the concentration of water. And if you talk about the concentration, the mole concept in Form 3, I don't know whether it has been moved to Form 4, but still the mole concept. You are talking about the concentration, moles per liter, molarity, the capital M. We have to calculate the concentration of water. We are looking at moles per liter. So you start by looking at the formula of water, H2O. Considering that is the formula of water, we have hydrogen atom, we have oxygen atom. But in that formula, we have 2 of the hydrogens and 1 of the oxygens. So you find that hydrogen has atomic number 1, mass 1. In this case, we are going to use atomic masses. So since we have atomic mass of 1 gram for hydrogen, but we have 2 of the hydrogen atoms, so we'll have 2 grams. 1 times 2 of those hydrogen atoms, it is going to give us 2 grams. But now, if you look at oxygen periodic table, you will find that it has atomic number 8. Mass will come to 16. If you remember very well in secondary school, the formula for finding masses is very easy. If the atomic number is an even number, you just multiply by 2, you'll get mass. For the odd one, except hydrogen, it was 2n plus 1. So for the oxygen, it is going to be 16 grams. 16 plus 2 of the hydrogens will get 18 grams. So you come here and equate. 1 mole is equivalent to 18 grams. Therefore, 1,000 grams per liter. Remember, we are trying to calculate the concentration of water. Moles per liter. Watt of 1,000 grams per liter. If you cross multiply, the grams and the grams will cancel themselves. You will remain with moles per liter. Then you put it to 2 decimal place, you will have 55.56 moles per liter. So don't include the units anywhere, just put the number 55.56 to represent the concentration of water. So you come and substitute 1.8 times 10 to minus 16, which was the KEQ value, which is very standard, equals to hydrogen ion concentration, which we still don't know, hydroxyl ion concentration, still we don't know, over 55.56. The first step was we were to calculate the concentration of water. Now we have calculated the concentration of water. It is 55.56. Now the next step which you are trying to, whatever you are trying to do here is 1.8 times 10 to minus 16. We have to put our 55.56 to the base of 10. It looks similar as the KEQ value, such that we have it at the base of 10 and a decimal. So in other words, we are going to put our 55.56, we are going to write it as 0.556 times 10 to power positive 2. Positive, you move 2 steps ahead. Negative, you always move 2 steps backwards. So if you move 2 steps ahead of 0.5556, you are going to come back to our initial value of 55.56. So you put it at 1.8 times 10 to minus 16 times 0.5556 times 10 to power 2, positive 2. Then you equate this one to concentration of hydrogen ions and concentration of hydroxyl ions. Then the next step, multiply 1.8 times 0.556, you will get 1.0, which is this one, times 10. You know, here we have 10 to the power of minus 16 times 10 to the power of plus 2. It means when there is multiplication sign, you are going to add those powers. So we are going to do like minus 16 plus 2 will give us minus 14. So that's where you get 1 times 10 to minus 14. You equate it to hydrogen ions concentration and hydroxyl ions concentration. Meaning, we have to revisit the definition of pH. The pH is negative log of hydrogen ions concentration. Negative log of hydrogen ions concentration, not hydroxyl. But in this case, the minus 14 is shared among the hydrogen ions concentration together with hydroxyl ion concentration. So we are going to share our 14 into the ratio of 1 to 1, 50-50. Hydroxyl ion will get 7, hydrogen ions will get 7. But remember, there was a minus before the 14, that is the minus inside the bracket here. Then pH was negative log, is the negative which is outside here. A negative will cancel a negative, it will be a plus. So the pH of water is